All right, this video is going to be about form and type and order and all things to introduce you into differential equations. I included some snippets from our textbook. I'm not going to read through it word by word. I'm just going to use it as a guide to explain some of these foundational topics. So our course is just your first potential course in ordinary differential equations. There is an entire other course that you can take, a junior, senior level course, even graduate level courses on partial differential equations. So this first example shows you the difference between those two. Notice in our one here on part A, all of these are just normal derivatives. You might have some parametric curves, but everything is just in like first, second derivatives as normal you would take in Cal 1 and Cal 2. However, there are partial differential equations which would require you to know some Cal 3 topics. And that's not a prereq for our course, so we don't go down that route, but just know that that they exist, okay? All right, the other thing that, or the next thing that you would want to make sure that you understand is the order of the differential equation. All that it means is that is the highest derivative in the equation. For example, we would call this a second order because the first notation says take the second derivative of y, or this is like y double prime. But be very careful because if you look at that second term, it says essentially y prime and then cubed. That notation does not mean take the third derivative. It means take the first derivative and then cube it. Therefore, this would be a second order differential equation because that's the highest order of the derivative in that equation. There are then a couple forms that you will want to know when it comes to writing out differential equations. The first is differential form. One thing I want to make sure that you note here is if you have a function of x and y, you learn in Cal 3 that you can take the derivative of with just respect to x and the derivative with just respect to y. When we do that and you find the differential, one notation you could write is something like this, meaning take the derivative of f with respect to x, take the derivative of y with respect to y, and that would be called differential form because you are actually finding the differential of each one of those pieces. Another form that you might see is called normal form. And if you have any kind of function of x and a couple different of its derivatives equal to 0, then you can move that nth derivative to one side and then have a function of x, y, y prime, what have you, on the right-hand side. This is just a first order in normal form where you have the derivative of y with respect to x on this side, and then some function maybe with x's and y's on this other side. For example, a normal form equation might look like dy dx equals e to the xy. This is in normal form because it's first order, and that's what's on the left-hand side, and then a function of x's and y's is on the right-hand side. You might also have something like the second derivative is equal to the first derivative times e to the x. That would then be a second order differential equation. And then I have a function in terms of x, y, and y prime, one derivative smaller on the right-hand side. However, the form that we need to know the most important form that we will work with in our course is called the linear form. A function is in linear form if it follows this format. Notice that all of my terms in front of my derivative pieces are all functions of x. And then I have the nth order here. It decreases in derivative order down to just y. And then you have a function that's just including x's on the right-hand side. Here are first order and second order examples of linear form differential equations. Here's our example that I want us to do together. We're going to identify the order of these all first. Then we'll talk about whether or not it is in linear form. And if it's not linear form, we're not going to worry about if it's differential or normal form or neither. We're just going to say, yes, it's linear, or no, it's not. Looking at A, I'm noticing I have y double prime as my highest derivative. So this would be a second order. On B, I'm noticing I have a third derivative of y and then a first derivative raised to the power of 4. Therefore, this is a third order differential equation. On C and D, both of these are second order differential equations. Now let's determine if they are linear or nonlinear. Remember, for it to be linear, I need all of my derivatives of y and my function of y to be on the left-hand side, and only functions of x on the right-hand side. When I'm looking at these 4 examples, I will go ahead and tell you that only A and D are linear in form. Notice that everything in front of my derivatives is a function of x, and I only have a function of x on the right-hand side. Same here. There's just 1, but that's fine. And 0, and that's fine. So both of these are my linear form. B is not in linear form because of that y prime to the 4th. I cannot have any powers of derivatives and have a linear differential equation. C gets a little bit tricky. The left-hand side looks perfectly fine. The problem is the right-hand side. If it is a little bit confusing to have this in terms of not x and y, you can think about this as y double prime plus y prime plus y equals the cosine of x plus y. Remember, on this right-hand side, I need only functions of x. Because there is both an r and a u in this original, or an x and a y when I decided to rewrite it in terms of x and y instead, it is not going to be linear in form.